The project name is Face Authenticated Touchless Interface for gesture-based interaction and personalized file access using Raspberry Pi. My guide name is Mr. K. Raghaprayami, Assistant Professor, Department of Artificial Data Science, NC Engineering College, and presented by uh, AI&DS student final year. My name is Kevin T. and my teammates are Akash R and Abhishek Raj. Okay. Okay. Abstract, Introduction, Literature Review, Methodology, Experiment, Result, Discussion, Conclusion. Okay, next first we saw that abstract. Abstract. Our main abstract is hybrid multimodal framework. We can use both the face recognition and the gesture-based control, hand recognition. Let's get into the topic. Hybrid multimodal framework. The system introduces a touchless interface for Raspberry Pi 4, facial recognition and gesture control to create a secure physical contact-free computer interaction. Lightweight deep learning integration. You can use the lightweight models like a MediaPipe and 21 landmark hand tracking and TensorFlow Lite for CNN-based facial embeddings. Okay, next we can saw that identity-based security. Beyond simple navigation, the system provides personalized security by using VeraCrypt encrypted volumes and specific file management. Optimize real-time performance. Experiment results demonstrate 98% precision rate. We can get the 98% of accuracy and 30 fps processing speed with a sub 100 ms latency, ensuring a responsive user experience with zero false positive during authentication. Okay, next topic. Problem. What is the main problem we can solve? We can also use the traditional input devices like keyboard and mouse in shared workspaces, present hygiene concerns, cause physical fatigue, lack integrity security for sensitive data. Scope. This research focuses on developing a touchless multimodal interface for Raspberry Pi 4 that combines biometric security with real-time gesture-based navigation. Strategy. The main strategy we can use that MediaPipe for 21 landmark hand tracking and TensorFlow Lite for CNN-based facial recognition to provide hardware-free interaction model. Next, we can plan. What is the main plan we can do to achieve high performance on edging devices by utilizing Clahe preprocessing? Clahe preprocessing, I think that contrast. We can adjust the contrast for the to get the high clarity data from the user. Solution: hybrid interface that uses facial authentication to unlock VeraCrypt encrypted volumes. We can unlock the VeraCrypt encrypted volumes by dual hand gesture to browse and manage personalized files. What is the main benefit we can get from that? Delivers a secure, low latency solution with 97.5% authentication accuracy. Authentication. We can authentication who are the user can use and what are the data privacy we can manage. Introduction. Next gen HCI. Next gen HCI is nothing but next gen human computer interaction. A touchless interface for Raspberry Pi 4 that replaces physical mice and keyboards with facial recognition hand gesture to improve hygiene and ergonomics. Secure authentication. Use CNN-based facial embeddings and TensorFlow Lite to provide identity-specific access to encrypted file with 95% accuracy. Precision control. Leverage MediaPipe for 21 landmark hand tracking. We can use 21 landmarkers in our hand. Our hand is covered 21 landmarking and what are that? We can use that pinch to click. We can use two fingers to pinch for the clicking process. Each optimization achieves real-time performance up to 30 fps on low-power hardware using Clag preprocessing for low-light reliability and local processing for data privacy. Literature review. Evaluation of human-computer interaction. Research shows a significant shift from physical input devices to a vision-based interaction to reduce user fatigue and improve satisfaction touchless interfaces. Hardware optimization. Previous studies have focused on tuning computer vision algorithms specifically for Raspberry Pi 4 architecture to ensure high precision when mapping gesture to OS commands. Real-time framework. What are the real-time frameworks? We can use that MediaPipe and TensorFlow Lite to achieve low latency performance and high accuracy in real-time identification and tracking. Integrated security graphs. What are the integrated security? Gesture matched gesture control. That is nothing but gesture and gesture based means with verification and identity physical file accessing and struggling with environment challenges like low lightning. In low lightning, we can access file in a better way. What is the methodology we can use? We can see that methodology pre-processing authentication, pre-processing authentication, video capture. We can get the video capture from the user and let's get into the next access control. Who can access that? And facial verification principle light clarity enhancement to adjust the contrast for the better clarification. Next hand gesture mapping. Left hand for scroll and right hand for click. Temporal filtering, Kalman filtering we can use and OS command layers by auto GUI can use smoothing and execution for next workflow, hand gesture control workflow and facial recognition workflow. First start camera, flag a filter applying and apply flag filter to the media pipe, convert color space, blue BGR and RGB, red, green, blue, that species, discard frame, confidence, check the confidence, left hand scroll and left hand gesture, scroll file list, select open file, scroll file open, spatial mapping. Next, we can use the facial recognition. Who can access the files? Start camera steam, apply flag filter, media pipe face detection, discard frame, palm hard drive and personalized file access, user authentication to enroll to user database, access denied, system locked. No means access denied. We can process means the facial recognition will happen and next go into the OS command execution. Okay, next get into the next topic. Raspberry Pi workflow. Raspberry Pi workflow means Raspberry Pi, the actual workflow is pre-processing layer, CPU, RAM, micro SD card that are in that Raspberry Pi. Raspberry Pi camera module is inserted to that and a micro SD card is inserted to that. User authentication, physical LED, software automation, power supply, HDMI display. We can connect to the Raspberry Pi and use the software logic is media pipe, Python scripts, OpenCV. Next, that is the actually the picture of the workflow. Left for that scroll and click. Okay, next go into the topic. This is that real time, which is real time happened. This is the my team member Aga. We can think that this is Aga's face detected. Aga's face detected. Next go into the file accessing. Okay. Next get into the programming part. OpenCV2. We can use OpenCV pipeline, OpenCV libraries, facial recognition library, pickle, media pipe, PyAuto GUI, TK, Tkinter, OS time. PyAuto you will check the screen and loading your face data, get into the encoding your data. Okay, MP hands. This for our hand recognition module. Maximum number of hands, one hand will be work into that one to spaces. Vault open, false, vault win, non open. Next let def open vault. We can use the function to actually work on it. Def open vault, global vault win, vault open. If vault open means return, vault open true. Next get into the process, vault unlocked. That will show that green color for that green color box will appear for that vault is unlocked. And let's get into that your files will actually open your files and you can actually work with the tower files. Next, the next part of coding, dep dist p1 and p. This is the function actually also return p1. P1 means nothing but the plots. Pinch. We can use the pinch. Return dist tips. First line pisting means nothing. This is the actual values you can hand marking have that. CV2 will check that. And the last phase time click cool down while true means red frame equal to cam read hand result hand tracker pre-processing RGB. If a hand result multi-hand landmarks means if is fist. This is the final conclusion part. Okay, if vault open means vault unlocked. Else CV2 rectangle put text vault locked. Okay, this is the actual is for vault is open means vault unlocked. Nothing is means locked. Gesture label CV2 put text. Okay, vault win means vault win update. Except exception vault open equal to false. Vault win non. CV2 wait key of order queue break. Okay, the final is the print goodbye. Okay, next we get into the result and discussion. This is the actual result for that our model. High recognition accuracy, 97.5% mean average precision for facial recognition of 50 to 100 centimeter, range and 90% precision rate for hand gestures. Real-time performance, pro strategic hardware optimization and spatial downsampling, the system maintains a consistent throughput 23.8 to 30 fps rate. Environmental robustness, by implementing Clahe preprocessing, the framework significantly reduces false rejection rates FORR in low light conditions less than 200 lux, overcoming a common limitation of traditional input vision systems. Okay, edge computing efficiency means nothing but that the project demonstrates the lower input resolution 320 into 240 reduces inference latency by 62%, allowing complex biometric and gesture tasks to run locally without cloud dependency, thereby enhancing data privacy. Okay, our project is finished.
Okay, let's get into
Uh,
the real-time demonstration. This is monitor of our HDMI. We use HDMI port to connect the monitor. This is Raspberry Pi. Let's that then the webcam for face detection, the gesture access. Okay, first we can access that first we access the Raspberry Pi. Okay, vault locked, face hidden the face on the vault locked. So then unlocked and show their face. Vault unlocked and hand tracking is on. Okay, and pinch to click. He's click that. He clicks that file. Vault locked because that he can hidden the face. Okay, vault unlocked. Then that click the file. Click the text file. Okay, he can access the file. Then back to that. Okay, we can access that the system only use faces for unlocking and then hand tracking. Okay, that is my project also. Is okay, access the second file. Password start text and detected pinch to click bank pin 4782. Okay, that is our project. Mainly that is the webcam and Raspberry Pi, and this is the monitor for our Raspberry Pi. We can use that. Okay, the final project is completed. Okay, thank you for our valuable cooperation.